Hey, everybody, welcome back to the 27th episode of Taps in Patience. I am AJ with Design the Everything here with Harrison of Precision Ingenuity. Hi, Harrison.
What's going on?
Uh, I'm breaking taps. Not
Hey,
not the YouTube channel, but we're back to our namesake of Taps in Patience.
yeah, a lot of breaking taps. I will
Yeah.
say I have been fortunate in the fact that I haven't broke a tap in a while, but I want to hear what's going on with you.
I have broken probably, at least 10 taps in the last 3 days.
Oh
At
my,
least.
why is that?
Well, because I go to tap a hole and then they break. I wish I could tell you the exact reason why.
Are you using the correct size drill?
Yes.
Are you using an oversized drill? So I have switched exclusively to about a 70 to 60% thread engagement on all of my drills, and I haven't broke a single tap since.
Yeah.
Um, Now on aluminum, I can get by with the 75% thread engagement. Um, but I even then I'm happier at the 70% ish range. And what's funny is I noticed this the other day, and I didn't notice it because I didn't have a table that had the form sizes until recently as a percentage. But when I got my drill bits and my form taps originally from um, what is it, Titans of CNC, when I first got my machine, their drills that they recommended are oversized
Oh,
slightly. They're
really?
like they're like a 70 or 65% thread engagement. Um, and I didn't put two and two together until I started paying closer attention to that stuff, because I always just used the two together and I never checked the sizes. But I
Yeah.
did the other day because I had the chart and I was like, oh, they selected something that was just a little bit oversized, so it's not 75% thread engagement.
No, maybe I'll
So
order some extra drills today. I'm running out of things to try. Like, okay, so I should give background. So I redesigned my carabiners. The new
mhm.
version of the carabiners have four tapped holes. They're tapped A80, which is very, very, very small. It's the equivalent of like a M1.2, I think, or M1 maybe.
Yeah, that's tiny.
Um, they are very small threads, and they are about 3/16 of an inch deep. So it's like, approximately a 0.06 inch thread that is going approximately like zero point 0.2 inches, 0.19 inches deep. Um, and in grade 5 titanium. And I have
Yeah.
just been breaking tap after tap after tap. I'm testing different variables. I went from I've tried bottoming taps, I've tried plug taps, I just tried form taps, and all I have been doing is breaking taps.
Um. Okay. So we'll troubleshoot this a little bit. Have you played along? Like, what brands have you been using? Have you been paying much attention to brand selection in your taps?
Um, so far, they've been either OSG or whatever brand McMaster carries.
Okay. Those are going to be good brands. So yeah, I would say drill size. Although when you get really small, the difference between a 70 or a 75% and a 60% is only going to be a thou or two.
Yes.
Um, but I do believe it'll probably make a difference.
Yeah,
Um,
I will definitely try that because that's a quick, cheap, easy thing to try. The Let's go through what I have tried. So I've tried different taps in different varieties. I have tried not using coolant and using a like actual tapping oil instead of coolant. Though I have not tried that on the form taps yet. That'll be my next experiment. I have also tried peck tapping,
can,
which
can the tor-
was new to me.
can the Tormach peck tap?
Uh, Theoretically, yes. I should say that I've not successfully done it yet, but
If you
theoretically, yes.
if you figure that out, let me know, because I was curious because it's got the encoders. If you were to tell it to go to a deeper depth, like say you drilled a tapped hole on Tormach, and this is a question for any viewers out there who might be listening, and including AJ. If you were to tap a hole, find out it didn't go deep enough, And if you were to offset it in Fusion, would it start at the same rotation and go deeper?
That I don't know. It probably would as long as you didn't change the top height plane.
Mm-hmm.
However, there is a cycle for pec tapping, and it does seem to do it. So
That's cool.
I had to update my post because I was using, like, I have a modified version of the Zoom speed post, and that didn't have the pec tapping in it. But I did some Googling and I found out that the new Tormach post does have the pec tapping, like new as of December. And
Now,
so I was able to copy paste the code across.
speaking of which, have you updated your Tormach recently?
Uh, ish. I don't remember the last time I did it. What when that
Because
was, but
I just noticed, and I don't know how recent it was that it came out, but they just included look ahead for the
oh
Tormach.
really?
Yeah, in the latest version. I'm gonna update tomorrow, but I was perusing Tormach's news stuff, just kind of looking around at some stuff, and I saw a video that was posted. I don't know if it's been within the last week or two, um, and it was just talking about the latest version and how it had a couple of premium features. I think that's how originally I saw it was on YouTube. Like I didn't realize there was a premium version of Pat Pilot, but they said they were bringing premium features to free, making them free. And so I don't know if they mean like they had a premium version of Path Pilot, or these are premium features found on premium CNC machines that we're bringing to Path Pilot.
That
And so
sounds more like what it is.
and so I was a little confused on that aspect of it, but the premium features for free is what kind of caught me in the subtitle or on the subtitle of the video. And so I was watching it. And after that, I went on to Tormach's website, and because in the video they also said that there was an area where you could do a feature request, and so I submitted a feature request where I wanted to have a page, and it could be. And here's my thought process on it. Actually, no, let's put this a pin in this because I can go on really deep, and let's finish
Okay.
up your deal.
So let's see. I tried using oil. I tried pec tapping. I've tried form taps. I've tried normal taps. I've tried bottoming taps. Um, I think right so far my most successful thing has actually been with a regular plug tap with the oil. However, I only had one of those. And for some reason I've always just ordered bottoming taps and it hasn't been a problem up until now, but the form or the regular plug taps seem to be the most successful.
Okay,
Um,
quick question. Have you are these straight flute taps or are they spiral taps?
they are straight flute. I don't think McMaster had spiral flute in Odd 80.
Okay,
And the
because
form taps are no flute.
are these through hole?
They are through hole.
Do you have an area in the bottom for the chips to evacuate to?
I do, though that hasn't really been a big issue because the taps are breaking in the top 25%,
Okay.
with a few exceptions. But the the last thing I have to try, other than thread milling and now drilling slightly bigger holes, is I ordered a floating tap head. And I'm thinking there may be some kinematic mismatch here going on. And so maybe that will fix it.
Maybe. I've tapped a decent amount of Aught 80 because that was the hole size for my original deck defenders.
Yeah.
So I did a whole bunch of Aught 80 in those.
I have never had an issue with tapping before, except for that one thing that happened that we won't talk about that named our podcast. Um, like I I have done plates that had like 100 or probably 200 M4 holes in them, no problem. Um, but even earlier, so another part of this was I was making a new fixture and it had a bunch of 440 tapped holes in it. And I kept breaking the 440 taps. And those things are like monsters. They're huge compared to the odd 80. And those would last more holes, but they were only lasting like 20 or 30 holes, which they should last way, way, way more. And so I'm kind of wondering if something is wrong with my machine kinematically, like maybe something to do with the new spindle, like maybe the RPM is a little bit off or the encoder is a little bit off. I don't even know how to troubleshoot that though.
Have you tried tapping with anything other than 80 since you put in your new spindle?
The 440s.
And they didn't have any problems?
No, so those were, I was breaking those too.
Oh, you break?
I broke 3 or 4 of those.
Oh man. Yeah, it could be something related to your new spindle. Are you starting is it starting to thread higher than, like, is it starting to thread and then going into the material? Do you have your height set correctly?
Yeah, one of the, like, I was doing some reading online, and one of the suggested troubleshooting tips was to move your top height up. And so I moved my top height way above the part. That way the spindle definitely has time to get to the right speed and maintain it.
Do you have a lead-in chamfer on your holes?
I do not.
Okay. That's another thing you can try. I try to do a lead-in chamfer, and I try to set the chamfer to be about 5 to 10 thou larger in diameter than the final thread depth. If that makes sense.
The thread depth?
Like if you were to measure the tap and measure the diameter of the thread, like measure the diameter of the tool, like I want to make sure that my chamfer is bigger than that. So
it's bigger than the major diameter of the thread.
Yeah, I couldn't think of major diameter. I was just thinking like the diameter of the tap.
I can do that. I might have to do with a ball mill. I don't know if I have a chamfer mill that's small enough, but
you can just peck it like a drill cycle.
Yeah. Oh yeah. But I don't think I have a chamfer mill that's small. The one I have has a flat on it.
Oh, it doesn't go
have
to
a sharp,
point?
pointy bottom. Yeah.
Oh, okay.
But that's fine. I can just use a ball mill.
Yeah. But
I'll try that. I'll try that tonight.
Yeah. Because that might help. Because I have noticed that helps. If you're breaking in at the top, that's the only thing I can think of on the top side that could help.
Yeah, it does get like, I don't know, like I said, like 25% of the way in, it seems.
Yeah, then that might not do much.
Entry, but
that might not do much. It might help a little bit. If there's any sort of misalignment, it would help guide it in better. But I don't know.
What RPM do you tap at?
It is all over the place. It depends on material, tap size. What I typically do is if I try to look at the manufacturer's recommendations, and I typically try to shoot for the lower 50% range, somewhere in there. And it kind of depends on if I'm doing aluminum or stainless or steel, and how much confidence I have in my ability to tap it. The lower my confidence, the lower my SF I am to that bottom threshold.
Well, at this point, if we're going off of confidence, I'm tapping at like 3 RPM.
Oh wow, that's really slow.
No, that was a joke.
Oh.
I'm tapping it. I've tried 350 RPM. I've tried 500 RPM.
Gotcha.
I haven't gone faster. I could try going faster. I don't know what it would do.
No, I wouldn't go above 2,000. I haven't really had any luck tapping above 2,000 with anything.
Should I try like 1,000? Just see if going faster does it.
That's kind of the range. I'm usually the low end. I'm around 300. The high end, I'm around 1,800.
Okay. Yeah, I've never tapped anything that fast. I think the fastest I've tapped on this machine is 500 RPM.
1,800 is about the fastest I've done, and I'll do that on aluminum with smaller taps like that.
Well, I mean, with a tool this size, I think my surface feed is like 4.
I'm not worried about surface feed and those smaller sides as much as I am if I go too fast. I'm just worried about overshooting the bottoming of the hole. Because there was an instance where I figured out, so when your Tormach is tapping, there's got to be some deceleration period, correct?
When it turns around, you add a dwell time?
no dwell time. What's happening is the machine's got to slow down and try to stop at the bottom height. Well, I noticed, um, and I did some experimentation. It's decently consistent, but it doesn't bottom the it doesn't go to the depth that you say in Fusion.
That's
And the
interesting.
faster the RPM you go, the further off it gets from making it down to that bottom height because it's trying to predict it based off of acceleration rates.
Okay, inertia. Yeah, that makes sense.
And so the higher your RPM goes, the more variation there is in if it's going to overshoot or undershoot. It tends to undershoot more than overshoot, but it's if I've when I was tapping over 2000 RPM specifically, that's when I started really noticing that problem, and so that's why I've kind of tried to keep it on the lower end of 2000.
Hmm. Is there, do you know, is there a torque requirement difference if you tap faster or slower?
Um, I it takes. What do you mean by that? I guess I'm
Like,
confused.
is it putting less torque on the tap if you tap at 300 RPM versus 3000 RPM?
Um, yes. So like if you go too slow, um, think of it like plowing snow. If you go too slow, that you don't have enough momentum to push through the snow. Versus if you go too fast, you run into the opposite problem. So you gotta find that middle ground where you have enough momentum to keep the snow moving, but not so much momentum that you can't stop.
Yeah. Maybe I'll try 1000 RPM just to see if it makes a difference.
That's kind of that's a. I mean, I didn't realize you were quite that slow, but yeah, I would probably try that with something that small.
Yeah, I've tried, like I said, I've tried 350 RPM and I've tried 500 RPM.
Yeah, that's a big range jump. So
350 and
like,
500?
huh? Oh, I was thinking 5,000 for some reason.
Yeah, no, 500.
Oh,
It's not a
okay,
very
yeah,
big range jump.
yeah. Sorry, I was adding a zero in there in my head for some reason.
Yeah.
Yeah,
And 500 RPM is only 8 surface feet for anyone
yeah. No,
interested.
you can go higher than 500. First, man, for the back of my head, I've had this whole time. I'm going 5,000. Man, that's really fast.
No, I'm not a
Um,
speedio.
yeah, no, yeah. Sorry, um, I'm adding zeros in my head. So yeah, I would say you could go up to 1,000, and possibly up to 1,500. Would probably be the upper limit that I would recommend.
Okay. Yeah, I'll try 1000 just to see if it changes anything. Like at this
Yeah,
point, I'm just looking for variables that change things.
I
And
did notice. I did notice with aluminum when you go slower because it's gummy, it'll stick to it and has a higher chance of breaking.
that
So
kind of makes sense.
I have had that problem in aluminum where if I run it faster, I'm less likely to break it because it doesn't stick as easily.
Titanium can get gummy when it gets hot. It's not so gummy when it's cold.
Yeah.
Um, could I be like work hardening when I drill it? I
How
don't
are you
think
drilling it?
so.
Are you plunging it? Are you tap? Are you
I
doing it in
have been
steps?
pecking it. I was
Okay.
having this was a different story and actually a pretty good testament to carbide drills. I was having birds nesting issues and I went back in and I checked my speeds and feeds on the drill and it was doing 15 thou per rev on a 3/64 drill.
Yeah, that's
Um,
way too much.
it's way too fast. Basically, the chips weren't breaking because they were super thick.
Yeah.
Um, I don't know how that happened. That was either a typo, probably. I think I missed a decimal point.
Well,
Um, but I did not break that drill. That drill held up really well. But
so if
I slowed it down, and that solved my bird nesting issue. But I
have
also
you
turned on peck drilling. So maybe if I turned off peck drilling,
maybe have you noticed in Fusion where they've kind of changed it where where it doesn't default to feed per rev or for chip per tooth with
there's
drills?
like a checkbox.
Yeah, I know, but if you check it and do feed per tooth, it gives you a warning that it doesn't work with at least with the current version of not Path Pilot, but the post processor I'm using, it gives me a warning and says it can't output in that mode.
Huh, I don't have that issue.
But anyways, I did notice that some of my drills, whenever Fusion made that flip, it messed up a lot of my speeds and feeds for my drills. So
Um,
and that's what I'm saying. That could have caused the problem that you're having.
yeah, it could have.
Um,
I think you need to update your post. The new one doesn't have any issues with this.
yeah, probably do. I've done it once since I had the machine, and I think it was when we first started the podcast. So probably need to do it again. Um, but yeah, if you are going so fast with, so let me ask you this: on the back side of your holes, do you have any material that's like being blown out? Okay, that's usually a good indication that you're going too fast. At least in stainless, if you're going too fast in stainless and building up too much heat, it'll the very end where it's breaking through will just kind of deform. And I actually had one hole that it was building up so much heat that it was going out, because I was going out 50 thou past the hole and it still wasn't breaking through on the backside.
Yeah,
because
that kind of sounds like when I was doing the first batch of carabiners originally with the feed mills, and like it would just kind of stretch the titanium out.
Mm-hmm. Yeah, I've had that happen with drills if it gets too hot and it's going too fast, and so if I slow it down, it kind of mitigates that.
And I will say, oh, sorry.
No, that's it.
I will say, dramatically, when you're trying to talk, that I have changed tools, so I'm not using that feed mill anymore. I'm using a Kyocera 3mm 3 flute. And granted, I haven't done production yet, so maybe tool life will be an issue. That's the problem I had with regular end mills before. But there are no burrs, there's no nothing on the backside. And I spent hours and hours sandblasting to get off the burrs that the feed mill left. So if we can figure out how to tap holes, the production on these will be much easier than the last batch of carabiners. We just need to figure out how to tap these 480 holes.
Now, are they going to be? Are you going to have a screw coming in from each side?
Yes.
Okay. Cool. Is there any way with that in mind? Well, you probably don't want to flip the part. You're probably not flipping the part.
Currently, no.
I was going to say, if you're having a problem with your holes, could you tap it from going both directions and then not have to go all the way through it?
I'm getting close to doing that. I was talking to Fidget Things, and he was like, I would just thread mill it.
Do they have an AUT80 thread mill?
They make AUT80 thread mills. In fact, my favorite vendor on eBay has them, and they're only $25.
Seriously? Wow.
Yeah. So I think regardless, I'm going to order some.
Okay, I will say, yeah, I like thread milling. I've been doing it a lot more. I just did some thread milling for some gun taps, and thread milling was pretty much the only option unless I bought a specialized tap. It was for a 1911. It was a .236 or .235 hole by 60 threads per inch. Very weird size.
Yeah, that's like a super steep M6 almost.
Yeah. And there was 10 of those I needed, or 6 of those. No, 10. 10 of those that I needed to thread mill. And it took over an hour to thread mill them.
Yeah.
Where a tap, I would have run it in and out. So if you're trying to do any kind of like large production on these things, you can do the thread milling for your prototype stage to make sure it's all working good. But when it comes time for mass production, you need to get that tapping figured out.
Yeah, we're looking at, if we hit our goals, which I think are pretty reasonable, we'll be tapping 4,000 holes.
Yeah. Yeah, that's a lot.
But on the bright side, the cycle time has been so much reduced from the old design was basically 100% slots, and the new design only really has one slot. So, like, I don't know, it probably lands somewhere near where the old design was, even if I have to thread mill. So it's not the end of the world. So, but I would really rather it be 5 times faster than the old design.
Let me change gears and ask you a different question. Um, um, what material are you sticking on the side of these things? I think I've asked you that before, but refresh my mind.
Either brass or titanium.
I was wondering if you could kind of do what you did with your little add-on piece to whatever you're putting on the side, but if you're just getting them laser cut or something, then that doesn't make sense.
Doing what to it?
Like what you did on that little piece that stuck together, that your fix it kit for the first one. Having a similar installation
Oh,
method for these.
I mean, it's not out of the question. It would make production. It would add a lot of production
It
time.
would. I wouldn't recommend it based off of what your scale material is being made out of.
What did I tap? Oh, I tapped those odd 80.
Yep, but that was aluminum.
That was aluminum, and that was before spindle replacement.
Mm-hmm.
Yeah, okay, so I've done these before. I forgot that I've done odd 80 taps.
Oh
Yeah,
yeah.
that was perfectly fine. Like, that wasn't a struggle at all.
No,
I only
that's
broke
what.
one tap with that.
Yeah.
Um, huh. I completely forgot about those.
Yeah, that's the first thing I thought of when you brought it up.
I don't know what's going on. I feel like I need to try tapping a hole in aluminum just to make sure the machine still does it.
Yeah, that'd be a good way to do it.
Yeah, and I guess I can run the encoder test to make sure there's nothing weird going on there.
Is it tool changing just fine?
Yeah, still changing fine.
I mean, that uses the encoder. Granted,
Yeah.
it's not as precise as a tap, but
The only odd thing going on with the machine is I got a new drive belt and it's kind of squeaky,
hasn't
but
worked
I
in
don't
yet.
think squeaky belts will break taps.
No. Do you have enough tension or too much tension on your belt?
Potentially. It's definitely not slipping though. Like, it's
Is there
happily
in
breaking the tap off.
is there any way to check if you have any sort of misalignment in terms of tram,
Um,
or did you
that's
check
a
that when you installed it?
possibility.
Or did you check
No,
that
I
like is
didn't
it
really
because
check
if
it.
it's angled one way or another while
Yeah,
it's trying to tap?
and that could happen from changing the spindle. I'll stick like a precision ground bar in there and indicate it.
Well, what you need to do, and it would have been nice to have done it before, because my Tormach table is not flat
Mm-hmm.
when I first got the machine, and I think I talked to you about it way back when, and I swept an indicator between both sides and found that it was like high and low in different spots, and anyways, if you knew something that was perfectly flat, on your table, you could run an indicator out and sweep it between all four quadrants and check your tram in both directions. But that's assuming your table is level.
Yes. I think if I just put a precision rod in the spindle and an indicator on the table and then move the spindle up and down,
Yeah, that's another good way to do it.
I'll try
I
that
didn't think
too.
about that. Yeah, that's a good way to do it. But yeah, I would check that. Make sure your tram's good, because that would definitely affect it. It would have less effect on a drill because drills tend to bend and warp,
Yeah.
and they are like. In fact, I just saw a video on Instagram where a guy was drilling a tiny drill bit, and it was bending at like 15 or 20 degrees into a hole, like, and it was fine.
Drills are impressive. Like, drills will do a lot of things.
So it was kind of funny. Taps, not so much. So, what else? What else you got going on? So we've been talking about your drill problem for a bit.
Other than that, I mean, Scott's been here this week. Um,
How,
except today. He works from home today, but he was in here Monday and Tuesday, and Guess we worked 2 really long days both those days, and
I am sure it's a little bit different having someone in the shop. What's your first impression so far?
oh, it's been huge. Like, on Monday, I normally would have spent the first hour or two shipping packages and answering messages and stuff, and like I didn't have to do any of that. I was able just to kind of get straight into production. There's definitely a lot of like, hey AJ, how do I do this? Hey AJ, how do I do that? And it's like, oh well, I have never had systems in place for this kind of thing, so I guess we should probably kind of work those out.
Mm-hmm.
But I mean, for the most part, it's gone, very smoothly. Like Scott knows what he's doing.
Yeah.
It's just when I ask him to do things that he's never had to do before, like printing shipping labels from designtheeverything.com
Mm-hmm.
or, messing around in BackerKit. Like, it's definitely no complaints.
That is awesome. I am happy for you guys. I'm really I'm looking forward to what you guys are able to do. So
I mean, I've already done, like, between the two of us, we've already done like 2 weeks worth of work if it had been just me. So
that is awesome. So, anything else or?
I don't think so.
Okay.
What's going on over on your side? Well, not your side of the pond because that's the UK, but your side of the country.
Well, I'm going to come back to that conversation that I put a pin in, because after watching that Tormach video about stuff and needing to update my machine with Look Ahead, one feature that I've requested to Tormach that I'm really hoping they implement is some sort of macro page that shows you your variables, because I've been using I've been using it on my Haas and I absolutely love it. And I would think it would be very beneficial on the Tormach. Probably more so than it is on the Haas because it's a mill, not a lathe. And so what I was thinking was, and the way I did this feature request is, I know they have some variables that you can access by default, but it would be cool to have a page where you can see those variables and update them on a page, or just go to a page and just look through them. And then one thing that Haas does is they have that page where you can go look at it, but you can also choose up to 4 variables to display on your home screen when you're running a program. And you can label them what they are. And so, like, I have 2 of those variables right now for any time I'm doing a bar pulling operation. I type in how many I can get out of a bar and what number it's currently on. And so both of those are visible. And if I ever stop the program or want to restart it or do anything like that or make adjustments, I just go over to the macro table while the machine's running and update those values to whatever I want. And if I want it to stop or whatever, I can do that. Whenever it does, like, the next, if a bar can do 20, but I want it to stop at number 5, then I can set the total count to 5, so it stops at 5, and then I can up that count to 10, but still keep track of how many I've actually done. So it's just really nice to be able to do that.
Yeah, on the Tormach, it would even be nice, like, if you could just set that up for a simple parts counter. Like, just if I could count how many carabiners that I've machined, just to have an idea of how many I've done and how many more I need to do. Like, that would be huge. Because counting takes a long time. Like, why would you waste time counting?
Or just, like, how many parts did this tool machine before it broke?
Yes.
Like, every time a tool gets put away, like, indicate a counter. If you have a macro page where you can add those variables, you can add a simple line of code that would just increment that up every time it's called automatically, and then they wouldn't have to do anything for it, which would be awesome.
Yeah, that would be good. Or in my case, how many taps to get one part?
Exactly.
It's like the it's like counter. The opposite of the it's been this many days since I broke a Heimer tip. This part took me 6 taps.
Yeah. It's instead of miles per gallon, gallons per mile.
Yeah, exactly.
Oh, that's funny. Yeah. But anyways, so there's that. The second thing is I did the salami slice method today in stainless.
Woo-hoo!
So
always fun. How'd it go?
It was awesome. and sucked.
Oh,
Um,
really?
yeah, so my parts are flawless, but the
Hmm.
machine sounds like it's ripping itself apart.
Oh, it's just how slitting saws are.
Yeah, and I'm trying to mess with speeds and feeds and get it quieter, um, and do everything I can because it sounds so loud. But the finish is amazing. So
What saw and arbor are you using?
I'm using um, Harvey Tools slitting saw. Uh, it's a 1/16 inch thick, inch and a half or inch and 3/4. I don't remember which. Um, and then I'm using the oh Mari Tools Arbor. Um, and what's crazy is when I first set that thing up, I touched it off and I rotated the spindle and checked it, and it didn't change by a tenth over the full
Hmm.
rotation period. Like I haven't never had that happen with any face mill that I've used ever. Like it was like even when I retouch off the same tool on any tool, let alone something that's a slitting saw like this. And so I'm just thinking that at some point I need to go through and update all of my Tormach tool holders to Mari tool or
Hmm.
something and get some quality uh, ER collet holders because I think it would make a huge difference in everything
Yep.
after doing this. So it's just it's something that I have always told myself would probably make a difference, and this is the first time I've actually got a really quality holder to actually compare the other ones to.
Yeah, I have 5 nice Technics tool holders, and then the rest of mine are Tormach.
Yeah,
And I use the Technics ones for small tools.
yeah, yeah. I couldn't tell you how big of a difference it would or wouldn't make, but I was just really impressed when I first used it. So, anyways, it came off great. But it recommends 1 thou per tooth. Um, and
That
I'm
seems
running
high to
it
me.
at I'm running it at about 4/10 per tooth,
That sounds better to me.
like 2 to 4 tenths per tooth, in stainless steel, 304, and it recommended 5 times deep, 5 times thickness, and I'm
That seems
going
very thick to me.
and I'm going 1 times, so I'm going a
Yeah.
16th per pass, but I'm thinking about decreasing that to a 30 second, and then increasing my speed a little bit because I've decreased it down to where I'm running at like 200 RPM and like um my feed rate is about 2 or 2.1
It's
inches
very
per
slow.
inches per minute or something. Yeah.
I I was running at 500 RPM, I believe, in stainless with a 2-inch saw. You could probably go a little bit higher.
Yeah. So it just sounds so bad. So
It Slitting saws sound bad.
like
Um,
okay.
the Servent Solutions guys, like they played with slitting saws for a long time, and eventually they found like a super nice combination that was like at least $1,000 to get started on.
Mhm.
Um, and they said that doesn't sound bad anymore. But like anything under their super fancy, like Hoffman, I think it's Hoffman or Goering. I don't remember. We'll have to ask Servent Solutions. But they like it's a different style of saw that instead of having a central arbor, it's got like some sort of locator and then it's got 4 flathead screws in it. And
Okay.
so there's no material sticking down on the bottom.
Oh, that's cool.
Yeah, it's really nice. But I think the blades themselves are like $300 or $400.
Yeah. And I've wondered with the blade geometry. I was thinking about it a little bit because I watched a NYC CNC video, and he was talking about spiral tip chamfer tools, and I'm thinking about getting some of those because he was saying he was able to get better surface footage or better speed and better finish. Um, and I was wondering with like a slitting saw, you're basically hitting it with a bunch of paddles. So
Yeah.
if they had one that was like helixed or Like even like a table saw. If you've ever used a table saw, one tooth, like if you look at the teeth when they go, you have one
Yeah, they've
tooth that
got a
goes to the
set to them.
outside, one tooth that goes to the outside, and then one tooth that goes to the middle, and it's constantly alternating where it's
Okay, so
cutting.
that's how my slitting saw is.
Oh, mine is a bunch of flat faces.
Okay. Yeah, I have a staggered uh hold on. Maybe now you're making me doubt. Maybe it's one tooth, like every other tooth is smaller in diameter or something like that. I'd have to go look at mine. Anyway, I buy staggered tooth saws from Maritool.
Okay.
Um Now that I'm thinking about it, I don't actually know if that is a like left right thingy.
Yeah.
So I don't know. But yeah, I see what you're saying.
Yeah. Because I think that would help the harmonics of it a lot. Because this thing screeches like nothing else. And like when I was running it, Weston was like, "Dude, that thing sounds like it's about to blow up." And like when we got the parts done, I pulled it off, and like the finish is basically the
Like a
same as
mirror. Yeah.
like a mirror compared. Like it looks so good. He's like, "What?"
Yeah.
he's like normally when they screech like that, like the finish is horrible.
Everyone
So
I've talked to has always just said, "Oh yeah, slitting saws just sound terrible. Like you're not doing anything wrong. It just sounds awful." So I don't think you're necessarily doing anything wrong. Like if you haven't exploded a saw blade yet, then
yeah,
and don't worry if the slitting saw explodes at 200 RPM, it's not going to go very far.
yeah. But I want to speed it up in general because the whole operation before the slitting saw takes about to do everything, including a bottom side chamfer, which so the roughing out of the whole part and finishing of the whole part takes like 4 minutes. And then the chamfering with the underside chamfer tool, because it's such a long reach and I didn't get a very big diameter, I have to go really slow with it. That's about uh, 8 or 9 minutes for that. And then it's about 20 minutes for the slitting saw.
Yes. That sounds about right.
And it's
Um
like,
the
oh,
the way you get around that is you turn on tool breakage detection and then you start it and then go home. And then you come
yeah.
back and it's done in the morning.
We talked about that. Me and Weston were like, so do you want to risk setting up a bar and leaving it overnight? And I was like, if it wasn't the first day using it, maybe. But it's
Yes.
the first day using it. We have plenty of time to get these parts done. I don't feel like breaking anything right now. So
Yeah. The salami slice method is not time efficient. Unless
it's
your
material
machine would
efficient though.
otherwise be sitting idle.
It is very material efficient though.
Mm-hmm. It is material efficient.
So, but I'm happy with it. I was super worried about it, but it's turned out great. My first attempt that I tried with aluminum ended up being like when I set up the tool in Fusion, it's a 1/2 inch center bore, and I set that as my arbor size. And so the simulation was like, "Oh, I have clearance for days," and I ran it into the side. And what's annoying is I was like, I'm going to try it on these aluminum parts because they're real easy and it'll be a quick test. Sounded horrible. Now, granted, this is a for stainless blade or for harder material blade from Harvey, and Harvey has aluminum dedicated blades or slitting saws, and they have about 30 to 40% less teeth for the same diameter. Um, because the recommended speeds and feeds for aluminum with this was like 130 inches per minute at 5 times D. And I was just like, no, I am not doing that. But when I tried it in aluminum, it would start on the back side and then do the front side, and that was my fault for not specifying I wanted to do the front. And it was bottoming out on the back side, and I couldn't see it. And so it'd
Oh,
get to like the
yeah.
middle of the back side and just stop and stall out my machine. And I'm like, what is going on? And like I would like adjust some settings because I was trying to do 5 times D, but I was just trying to go slower. And I was like, maybe I'm going too fast, maybe I'm doing this, maybe I'm doing that, yada yada yada. and it kept stalling, and I kept changing things, and finally I was just like, okay, I'm gonna pull this thing out, and I pulled it out, and the whole backside of my part was just like rubbed raw. And I looked at the arbor because I hadn't been looking at it, and there's this like shiny spot where it's been rubbing on the top, and I was like,
Yeah.
oh no.
Whoops.
And that's when I realized that my arbor size infusion was, because it wasn't registering. Like I wasn't checking that. I wasn't looking for that. Like, it's funny the kind of tunnel vision you can get when you're trying to solve a problem, and then like the answer's staring you right in the face, but you
Yep.
just don't realize it. So, but anyways, that's been my adventure with the slitting saw so far. I'm very happy with it. I think it's something that if we can master, will help us to run a lot of stuff without having to stand in front of the machine as much.
Yep. Especially
So,
when you start learning to run it overnight.
yeah. Then I can just stick a bar and let it run. Which, by the way, how do you do tool breakage detection if you have the bottom part sticking out of the saw, out of the bottom of your slitting saw? Or do you just not break?
You just don't do it on the saw.
You just don't do it on the saw? Okay.
Yeah. Because if your saw breaks, let's see. Okay, so if a tool that's not the saw breaks, the tool breakage detection will detect it. If it is, and even if it misses it, the saw will just cut off the part still. And
assuming your saw doesn't break.
If the saw breaks, generally it airs out the machine. You'll break all the tools, or you'll break the next tool in line, and the machine will catch that.
I will say this though: in my first tests in aluminum with the slitting saw, my spindle aired out and it kept going.
That's not what I've seen before.
It did not stop my machine. My slitting saw blade came to a complete stop and it powered through and kept going.
Is it because you're at 200 RPM?
No. This was in the aluminum. I was much higher RPM at that point.
Huh, that's weird. Mine definitely airs out. Was your...
And see, mine had aired out.
Catch that.
Mine had aired out previously. But what it did was it like slowed down and came to a stop and then powered through it. And then once the blade got out, it's like the spindle reset and it started spinning up before it went over to the next side. But it came to a complete stop and for like a couple seconds going through it. And then when it got out of the part, it spun up and then kept going.
Mine definitely throws an error when that happens. Because I've seen it happen.
Yeah. This is not the first time this has happened to me before. I've had
I wonder if it's because you have an older machine.
Could be. I've had it stall out and shut down the spindle and keep moving, and I've had to e-stop it several times.
Yeah, it's not one I've seen before.
Mm-hmm.
Machines are weird. You think they would all act the same.
And what's annoying is that it does sometimes. Like it most certainly has.
It acts consistently sometimes.
It most certainly has stalled out the spindle and shut the machine off. So yeah, I don't know. It's weird. Like my machine does weird things sometimes.
Yeah.
And sometimes my steppers miss steps. My servos, but it's got the encoder, so it knows where it needs to be. So it'll skip and jump and then go catch up, which is weird.
Interesting. I mean, I guess it's kind of what servos are supposed to do.
Yeah, but you would think it would like throw an error code or something. Like, and it does if it gets too far.
Yeah, if it gets too far.
But
the question is how far is too far?
Exactly, because like I've got my speeds and feeds dialed in pretty good on aluminum, and I've had a couple parts where I'm using the Core 5 from Kennametal, where I'm right at the horsepower and torque limit of my bed, And like I've had it where I've had parts that were slightly thicker than planned, and it plows into it, and it's got enough momentum in the spindle that it doesn't slow down, but it stalls out whatever axis it's moving for like a split second, and then kind of catches up, and kind of you hear like a little clicking as it's like catching up, and then it's fine.
Yeah, it's definitely one I have not seen before.
Yeah, my machine's done some weird things.
I feel like mine would throw an error. Like mine throws an error too eagerly. Um, like when I first got mine, so there's like rubber bumpers on the ends of the
Mm-hmm.
axes, and when they ship them, they move the axis all the way to the end and they park it against that bumper. Well,
Mm-hmm.
sometimes just because like when you compress rubber for too long, it kind of wants to stick to whatever it's stuck to.
Mm-hmm.
My machine would not move off of those bumpers. It would throw an error. And like you have to open up the you had to open up the little box where the shaft coupler is and like throw some vice grips on the shaft coupler and like give it a wiggle to break it free of the rubber thing, and then it will, home for the first time.
Yeah.
I
Yeah,
want
I
they
haven't
must
had.
have just changed the tune on the motors.
I don't know. Like it just does weird things. Like it doesn't always stop when you think it should have. When it's like crashes or like runs or I'm pushing it harder than it probably should be. Like because I I try to push it to the absolute limit like most of the time. Probably not a good thing to do.
Which I do
Uh,
not do,
but
except on taps. I push taps.
I'm running it with the largest tooling at the fastest rates with the like if I were to go like 5% faster my motor would stall out.
Yeah.
Like that's how close I am on some of my stuff that I run.
Your problem
um
is you make big stuff.
yes, yeah. And if I slow it down at all, my part times go through the roof. And when I'm trying to do job shop work and compete with people that have like a Haas VF3 super speed, like yeah, my machine's like a fraction of that cost, but at the same time, I am trying to make a decent hourly rate. So, uh,
Yeah,
but
I'm like, wow, this part uses a 3 millimeter end mill. It's huge.
yeah,
I can push it so fast.
yeah. Meanwhile, I'm over here running um a half inch uh long reach end mill that's like 3.5 to 4 inches long, trying to get into deep pockets in aluminum on
Yeah,
on the Tormach, which is a wet noodle on the best of days. For at least for the type of work I'm trying to do, I should say. I mean, it does
I've
great for the small stuff, but yeah,
I've only used a half-inch tool in my machine once, and that was to get inside fillets. Like I wanted half inch, yeah, half inch diameter. No, half inch. Sorry, my brain's breaking here. Yeah, quarter-inch radius, half-inch diameter fillets on the inside corner of a pocket, and so I used a half-inch ball mill,
yeah,
and I've done that once, and that's the biggest tool I've ever ran on this
yeah.
machine. I have a face mill that I've still never put inserts in or used, but
No, I use my face mills all the time. I've got 3, so I love them. Although I've retired one of them
why is that?
because I found a better one. So I've got a 3 inch and a 2 inch, and my original 3 inch was the one that I got from. Um, it came with the kit for Titans of CNC, and I really liked that one. It did a good job. It just kind of, for what it was, it did great. Like it gave a really good surface finish. But then we wanted to do some face milling on stainless, and that wasn't going to cut it. And so I wanted to get a 2 inch face mill for stainless and steel because I hated using an end mill because it just wasn't as nice. Um, and we got a Sumitomo face mill, and we got it in the 2-inch variation, and it had inserts that could do both stainless and aluminum. Whereas the one I got on the Titans of CNC, it only came with aluminum inserts. I couldn't get steel inserts for it. And so I ended up switching out to a 3-inch version of the same face mill. And now I can put steel or stainless steel or aluminum inserts in both of them, and they're compatible. They can
That's
switch
nice.
between the two. So,
Yeah. I want one of the, and I may have this brand wrong or maybe saying this wrong. I think it's like Shroom Solutions, tri-flies. Have you seen those?
mm-mm.
It's like a three insert fly cutter kind of thing.
I really want to try a fly cutter. I haven't tried one yet.
Oh, I loved my Superfly on my old Tormach, but that went away with the old Tormach. I'm sorry, I'm hitting the microphone every single time here.
Okay.
I was looking. I want to make sure I get that guy's name right, but he's like a relatively small company. He's probably a little bit bigger than us, but he's not a huge company. Yeah, Shrum SHRUM Solutions. They have their tri-fly, which is a super cool looking
SHRUM.
I don't think he makes it in BT30. It comes in TTS, but I think it's either TTS or straight shank.
Oh, I've definitely seen that one before. I just didn't know who it was. Speaking of which, I'm looking at one of their photos on their website. Have you seen those really cool patterns you can get with face mills?
Mm-hmm.
A lot of guys do it on the golf stuff.
Yep.
Like the putters. I really want to try that at some point. Like I want to have like a product that I can do that finish on because I think it looks so cool.
Yeah. The Arcturus makes Scott, a different Scott. He does a lot of that on his coins with a boring head and moving it around.
Oh, really?
Yeah.
That's cool.
You could do it. You could fake it with a ball mill and
Yeah, you
ball
can
milling
fake
circles.
it. Yeah. But anyways, let's see what else. We have been doing work to our shop, trying to get it cleaned up and
Nice.
organized. And it feels really good.
Yeah, it always
I've spent
does.
every day this week doing some sweeping, mopping, and organization at least for a couple minutes every day. To the point where my dad came in and he goes, "Okay, you guys are getting a little obsessive here. Like, chill out." And because he's not, I'm not very organized. I don't organize very often, and I come from my father, and he's the same way. And so it feels good to kind of break out of what I normally do and get some stuff organized. So we're like in the mode of like foam everything, like foam inserts, foam cutouts for everything. Like we just redid our gun bench, and it is so much nicer. Like everything is right where you need it. It's just a grab away. Everything has a home and a place. And it used to be like we'd open the drawers and everything's rattling around, and it's just. I know you have the Gridfinity stuff.
Yeah,
But
so this is how I felt when I moved to Gridfinity.
yeah, so
And you too need to move to Gridfinity. Join our cult.
I like Gridfinity. The problem is that I don't have enough 3D printers to support Gridfinity.
I have one Prusa.
I have 2 printers, but they are running full
You have
time on
twice as
products.
much Gridfinity as I do.
But they're running full tilt on products.
Okay.
They have been
by a third printer.
We have been talking about that actually. We are in talks of getting a third printer. What we've been waiting for is the Prusa XL. Because the next printer we want to get a large format printer. And so that is on our list, and we really want to get it. One thing we did get today, though, Pearson palette.
Ooh, nice.
So we got that from Fidget Things.
Oh, okay,
Uh,
sweet.
so we got his used one. So it came in today, and we unboxed it, and we're getting it all cleaned up, and I got to figure out what we're gonna do with the pallets because I really want to get some products going, and I want to get them stuck on the pallets.
Yep.
So
I strongly advise you take one of the pallets and you stick some vices on it, or a vice, like whatever your
it
vice is.
one of the pallets that he sent with it is the Saunders. Um,
Ah, okay.
it's like a mini Saunders pallet, but it's for the Pearson pallet, and it's the exact size to fit our vice on it. Or we can take our vice off and put the Pearson mini, or we can put the Saunders vices on it. So it's
Or you could use the Saunders vices to hold your vice in place.
oh my goodness, that's like too much stack.
I
I've
had
I've, I've already told Weston. He's like, oh, I want to stick the our vice on it. I'm like, that's great. We already run into Z travel issues,
yeah.
so like we
I
have way too much stack up.
the other day I had like a fixture and a vice that was on a fixture plate that was on a fixture plate. Or a
Yeah,
fixture. I had a my part was being held via super glue that was on my super glue arbor that was in my Saunders Machine Works vice that was on my Saunders Machine Works pallet that was on my Saunders Machine Works fixture plate.
yeah,
It's
yeah.
like stack on stack on stack. But
So,
seriously, having a vice on one of those quick swap things is nice. Like
oh yeah,
yeah.
yeah. No, it's we definitely are going to do it. It's just I don't want to get so gun ho in that route because we do enough stuff on the Vice that it's like it'll work for most things, but there'll be times where we'll have to take it off.
You'll
Like
have to take the
today,
Pearson system off the table.
yeah. Like
See, that's
today,
just a giant, huge pain.
yeah, I know. Um, and I want to use it as much as I can, and that's why I really want to get into product stuff because if I get into product stuff, I can do it. Job shop stuff, I don't have a choice. If it's got to come off, it's got to come off.
You do have a choice. You could not take that job, but
Yes, but I like money.
yeah.
And I need money. So
Is it just Z travel that's your issue?
that in the tool changer
Huh, okay.
because it's so tall. I haven't actually used the Pearson pallet system yet, so but I know that like it's gonna add what 3 or 4 inches at least,
At
um,
minimum, yeah.
and so I already know that there are some really long, and this is because we use such long tools.
Hmm.
Some of the
Which
long
I
tools
don't,
that we,
which is why I don't think about this stuff.
yeah, some of our tool like when you're using when you're machining a part with a four uh 4 inch long reach half-inch end mill, um not only do you have the long stick out of that tool in the tool turret, but the part that it's machining is also really tall in a vise,
Yeah.
and the combination of those two means I have zero Z travel, and I have a special code that I wrote that moves everything to the side, does a tool change, then
And
brings
then
it
comes
back.
back.
And
Yeah,
I
that's
I only
fair.
have about an inch or two of total clearance in those instances.
Yeah.
So, which is why I really like being able to stick everything on flat on the Saunders fixture plate table and using the Saunders vices whenever I can, because that gives me a lot of extra room when I'm doing really tall parts that I just don't have with my 5 inch Tormach vise. So,
Yeah. And remind me, you have the Saunders Machine Works fixture plate, right? Like,
yeah, the
so
aluminum one, the bare bones basic.
yeah, theoretically, you could gain an inch by taking that off and mounting the Pearson system directly to the table.
Yes, but this Pearson system that I got from Fidget Things has the through holes to mount to the Saunders table. And
That is nice.
when he set the toe clamps, he forgot all the bolts except for one. So I have
I
all the
mean,
toe clamps,
bolts are
but I
replaceable.
don't have the bolts. I can get the
Yeah.
bolts. I mean, we have bolts, but I have 4 toe clamps and one bolt.
Okay.
Yeah,
Seems
Fidget.
fine to me.
I haven't actually talked to Fidget Things about this. I was going to reach out to him, so if he listens to this podcast, we're missing 3 bolts and the so we also got a vacuum system from him. Another thing that I haven't been able to
Oh, really?
find is he said that he had one of the end mills for the gasket cutters, and I did not I couldn't find that either.
It's also the Pearson system.
It goes on top
Hmm.
of the vacuum. It goes on
Yeah,
top of the Pearson pallet.
I one of those would have saved me a lot of time this week
Yeah.
because instead I decided to make my own fixture, and then I decided to put a bunch of 440 holes in it, and then I broke all those taps.
Well, I'm excited to use vacuum, but now I need to go get some air hose because that's the one thing I forgot to get. So I'm probably going to be placing an order to Pearson Work Holding shortly for some supplies. But I'm super excited though.
That
I've
is
wanted a
super cool.
I've wanted a Pearson pallet system for about a year now, and now that I finally have one, I'm so excited. But I also really need to get some products so I can take full advantage of it. So
Yeah, the Tormach, or excuse me, the Saunders pallets are fine, but they are slow. Like
yeah.
they're definitely not a quick change scenario. They're repeatable enough for what I'm doing, but like it's 4 fairly long bolts that you got to take out, and inevitably when you pull off the pallet, it always takes the dowel pin with it. Then you got to pull out the dowel pin, put the dowel pin back in.
Mm-hmm.
Yeah,
Yeah. So I'm excited for this. So, and ironically, a palette system that I conceived of over a year ago after looking at the Pearson palette system and I used for the very first time. I guess that's another thing I could talk about. So I have a homegrown palette system that anyone can do anywhere with
okay.
any vice. And it was an idea that I had over a year ago with some scrap material that I got from Xometry back when we were trying to devise product ideas and palette systems. So all I did was I cut 2 pockets into a sheet of aluminum, and I made sure that the back pocket was wider than the jaws, and then the pocket that would go against the hard jaws, I Mickey Mouse the corners to where it could always indicate off of the corner of the jaws. Um, and then in theory, you just set that whole thing down on top of your vise, clamp it, it grabs onto it, and then you're repeatable based off of that.
Yeah,
And I
that would be
used it.
fast.
I used it for the first time, and because we had a product that we wanted to test out, and I wanted to try out a palette system, and I've had those sitting. I made them all up about a year ago, and I finally got to use them for the first time, and it worked flawlessly. So I was really happy with it. But now we got a Pearson system,
Yeah, so it doesn't matter.
so it doesn't matter. Um, but it's a cool idea that anyone could do if they wanted to come up with a low budget palette system.
Isn't that kind of how the Orange Vice pallets worked? Didn't they work something like that? Like they had
Potential
pallets for their 6-inch vices.
Potentially, yeah.
I don't know enough to really know, but
I don't know. I'm happy with what we did, so now I just gotta put it to work.
I really need to make an ER40 pallet, like a pallet that has at least 2 ER40 like job redo, so I can stick stock in. And because I right now I can see it from here. I have a Saunders Machine Works pallet that has a mod vise on it that has my cullet block that it's holding that has the ER40 cullet. So it's again I have these like 5 fixtures all stacked up, and I'd
Yeah,
like to at least reduce some of those steps. So probably putting the easiest thing to do would be to take a blank Saunders Machine Works palette and just cut pockets in it for the collet blocks. I don't think I would want to try to cut a collet block directly into a pallet, but
yeah.
it would be handy. I think you
Well,
could
that's
get at
it.
least 6 on a table too.
it's interesting because I thought about creating my own ER collets today. So one problem that we have on our lathe, give you a little background on this. We got the Royal collet system on it, and it has a behind the main collet. There's a plane where you can have a backstop for your part to hit against. If you need a part that's longer, I have nothing to backstop it against
Okay, that makes
because I
sense.
have to take that plate out, and now it's just a through bore all the way through. What a lot of people, a lot of different machine shops will do is on the very back of your machine, there's 3 bolt holes, at least on the Haas there is, and you can bolt a plate up to it, and then you can stick a rod through that plate, and you can have like a set of set screws to lock it down. Um, One thing I was thinking about doing was instead of doing set screws, could I just machine in an ER collet receiver? That way, if I wanted to change out
Hmm.
the bar that I'm using as a
Yeah,
set stop, I can just change collets, and so I could use different size bars depending on what I'm doing, to act as my backstop. And maybe it might not matter.
makes sense to me.
It might not matter if once I have one size, I don't really need to change it. But I thought it'd be interesting if there was ever a need to change out the rod size for the backstop that I would have that ability.
What if you bought just like a super cheap Chinese like lathe collet chuck? They make them in like 3 and 4 inches, and they're like $100 or $120. That was the other thing I thought about, just bolting down to a pallet. Then you can just like bolt that straight to your sheet metal.
I wouldn't want to do that. That'd be too big and too much work to get it on and off for when I need to feed bars through.
Oh, you just pull off the you just pull out the collet.
Maybe I have to think about that.
I guess, how big of bars are you doing? Like, what would be your biggest size bar?
2.5 inch.
Oh, okay.
It's a 2.5 inch through
That's a
bore,
very
and
big ER collet.
yeah, it's two and a half
Yeah.
inch through bore, and we have done 2.5 inch through bar before. Um,
Yeah.
I need to get the Haas spindle liners. Um, that's another thing I need to do at some point. I just am cheap and haven't found ways to get
They
around it.
cost money. Yeah.
I have 3D printed my way through this problem many times. Instead of throwing out the $500+ to get them.
Is that for a set, or is that per each?
So I have a really cool system where anytime I'm using a material that I haven't used before and it's really long, if it's metal, it's I 3D print a plug that is tapered that goes onto the back of the bar and
Mm-hmm.
holds it in the center, and then as it gets pulled through, it just supports the back of it so it doesn't vibrate
Flip
around.
around. Yeah.
Yeah, the middle is completely unsupported. Um, but so far it has only been an issue on plastic, and I have a
That
low
makes
budget
sense.
solution for that as well that I have used. So what I did for that, and maybe I should take a video or some photos of this at some point. But I took a whole bunch of PVC pipe from like Lowe's, and I 3D printed spacers that would fit into the end of the PVC pipe, and then the internal diameter of them was a slip fit for the plastic that I was using, and then I just cut the PVC pipe in like 4 or 6 inch increments. That way, every 4 to 6 inches, I would have a supported section of
Yeah, makes
the
sense.
plastic part, and then I shoved that all the way in there and basically made my own low budget um,
Spindle liner.
spindle liner. Um, and then I just had a metal plate that I stuck on the back that held it all in there um, with a hole in the center. And then I could feed bars through just like it was a spindle liner.
I mean, if it
It
works, it works.
and I made this is before I had a part puller, which would have been awesome. But I turned 1,000 or 1,500 plastic parts through it without any issue. So I was pretty happy with that. Um, But yeah, it was funny because by the time we got done with it, there was so much heat in the spindle that I don't know if it grew the PVC or the 3D prints, but basically I'd made it a friction fit for the PVC onto the 3D prints, and it was basically a slip fit by the time I got done with that job. Like it was still doing the job of like I didn't need them to be a press fit together because all that PVC was doing was spacing everything out. So like when it was shoved in there, it was fine. But whenever I went to pull it out, it like came out in small pieces. So I had to pull all the individual pieces out, or shove a rod in from the other end to push it all out the back. Um, but it worked great. I was happy.
Well, I'm wearing down. Do you want to take us out?
Yeah. Um, Everyone, thanks for listening to Taps and Patience. Please continue to reach out to both of us. I know that I really enjoy getting messages from those who have listened to the podcast. And please like and share with all your friends. This is Harrison with Precision Ingenuity signing out with AJ from Design the Everything.